So I guess we'll get started. All right. Hello. Today we're going to be during the session at least, we're going to be taking a step back from looking at how AI is applied in some of the class settings and really look at where we are right now, where students are, what our actual technology infrastructure looks like for our students across different teams. So just to start, this is work that was produced from a partnership between myself, I'm Sheena Philippi, I'm an assistant professor and the science librarian at Brooklyn College, and my colleague CUNY, who is an associate professor and the overall librarian at City Tech. Caitlin couldn't be here today because of a conflict, but this is the work of both of us. I just want to make sure that that's very clear. And nice. And please feel free to contact either of us about it going forward as well. So this work, what I'm going to be talking about today is a survey that we conducted, but it was done in partnership with the New York City Tech Talent Pipeline. And so this is an initiative that comes out of the mayor's office. It's the Office of Talent and Workforce Development. And one of the main goals of this initiative is to build a strong workforce. So based on their own research and partnerships with other CUNYs, they've seen that since 2017, the number of students who are graduating with tech degrees, computer science, engineering, some sort of like tech-specific STEM degree, has more than doubled since 2017. And so there is a huge flood of students coming out of the CUNY system who are entering that tech workforce. So between this initiative and us, we wanted to see, are these students actually ready? Are they ready when they walk out of the door, when they graduate? Do they have what they need in terms of education and knowledge to be prepared to really engage with the workforce? And the work of this initiative really dovetails very, very nicely with the work that we do here at CUNY, because we're looking to see how we can best prepare students through quality education, through workforce development, just instruction and opportunities. How can we get them ready to be ready when they leave, to be confident that if they take a job, they can do that job. So in terms of, in addition to looking at whether students were actually ready, we also are informed that the mayor's office is also looking to see how can they fill any gaps. We wanted to understand what were the gaps in student technology needs. And would it be possible for every student who's coming in to pursue a computer science degree to actually walk in and receive a laptop on the first day of class? What can be done? What would be possible? So before we can see, what's possible, what's the next step, we need to see what are the problems, what are the issues we're having. So to do that, we conducted a cross-CUNY survey of CUNY students. It was a 24-question survey, and it aimed to understand both how students use technology, both inside the classroom and on other settings, on the campus, and then off campus, whether they have access to the technology that they need, laptops, desktops, internet, and how they actually engage with that technology to do their coursework, to answer questions, to just like really practice, to study, to do whatever they needed to do. So we also wanted to see just what were the students' needs and preferences in terms of both having access to more technology, more equipment, and just where they would prefer to study. Right. So overall, the survey was launched in the spring of 2023. It was open for about 4 days. We did offer an incentive, so we got a huge flood of participants right away. It's a tiny budget, so we did cap it. But we had participants from 14 different campuses, and so this was the breakdown overall. About 90% of them were from senior colleges, 10% from junior colleges. And then in terms of credits earned, so this is looking at the where in their academic career the students were. The majority of it, it was fairly equal across the board. The majority of students who participated were freshmen, so they had earned fewer than 30 credits within that semester. And then the next largest population were those who were closer to graduating. So between the newest and the most experienced students, that was the majority of our participants, but we did have a fair distribution across the board. So results. I guess before we jump into key outcomes, we did have a lot of results. We had a huge number of results because we did have a fairly long survey, but I did want to just highlight the results that I think were most relevant to the context of this conference. Because, you know, different questions that we asked would be relevant and important. And if I had the time, I would talk about every single one of them. I was really excited, like going through it. We looked at them in so many different ways. So we're working on a paper. It's challenging to cut. Like, what is the heart of it? So we've narrowed it down to just 4 key outcomes that are important when we're looking at this landscape, this new landscape of technology, and how students are engaging with AI and all the other new and emerging technologies. So looking at computer science students specifically, and the fact that they are not only consumers of things like AI and other kinds of digital products, but they're also manufacturers, they're makers, they're the people who are actually building them. They need to have the skills to know how to do it. But outside of class time, 57% of our students, use a campus computing lab to do their coursework. Of those, 40% use a lab 2 to 3 times a week. 20% borrow a laptop at least once a week. And so that's when they're outside of the classroom, when they're actually engaging with the material, how they're doing it. So they're mostly doing it on campus. And a lot of this is because they might not have the computing power that they need on their own personal devices. We did actually find that I think it's about 15% of students don't have a personal laptop that they can bring to campus and do work in. They can't really work with that setting. But even so, many more than that don't have a laptop that's actually equipped to do what they need to do. So it doesn't have the computing power. They might be working on something like a Chromebook, and it won't be compatible with the software that they need. So there are challenges in terms of just having the correct equipment. So having a laptop is not the only, answer to the question. About a third of CS majors specifically had unreliable access to a computer on campus. So even if they are staying on campus, they're looking for a computer that they can use to do their coursework, they're not finding it in about a third of the cases. And so this is different campuses, and we do have to acknowledge different campuses have different equipment, different resources. And then sometimes it's really just that they don't have, they have a computer, but it doesn't have what they're looking for to do what they actually need. So it might not have the software that they need specific to the work that they're doing. And then about 20% of students who progressed through 4 different computer science classes, including a programming class, had never had a class that was held in a computer lab. So unless they were bringing in their own computer, they were learning programming without actually programming. They weren't doing it themselves in the room. And it was about 15% of students who had taken more than 10 classes had never had a class held in a computer lab. So in the case of those students, again, if they don't have their own equipment, and if their equipment isn't equipped, then they're not having an opportunity to actually manually work with the material.
Thank you. For number 3, are we looking at 4+ classes in computer science?
Yes. Sorry,
I just wanted to say that, like, this semester I didn't have any.
Yeah, no,
It was like first class.
yeah, computer science specific. So all of the questions that we asked were about computer science specifically. And I do have a word cloud later that shows all of the different majors. About 88% of our participants were computer science majors, I should mention, but the survey itself was open to current students who were taking a class in computer science during that spring 2023 semester and had already taken at least 1 computer science class. So it wasn't specifically open to majors, but to students who had taken at least 2 computer science classes in their experience. And then the 4th key outcome, which I think is really very telling, especially when we're looking at all these other ones, is that the majority of students, about 70%, indicated that their ideal setting to do this kind of work would be at home. So many of them mentioned that they don't have, about 10%, don't have reliable access to the internet when they're at home, or they don't have a computer that they can use consistently when they're at home. And so they are required to be on that campus setting, or they have to commute. So some students did say regularly they do their work while commuting or while at work. And because of those kinds of life obligations, they can't really sit at home very leisurely and do all that practice that they need to do. So unless they're really getting just hands-on experience in the classroom, which we're seeing that they might not because they're not going into computer labs, they're not actually getting that hands-on experience in the class, they're relying on being on campus to do all of that work that they need to do. And so, as we all know from our students, we're a commuter campus. They have to spend hours. Some students have like 2 or 3 hour commutes, and they have work obligations, they have family obligations. And so all of those things together do combine to make a really difficult environment for them to get that hands-on experience and get that hands-on practice. And without that practice, they're not going to be confident when they're leaving the classroom and trying to enter the workforce. So that's one of those really big concerns or problems. And as we heard from the keynote this morning, these challenges create some opportunities. So hopefully we can look at it in that way. That was fun. So implications. So looking at this from the perspective or the lens of universal design of learning principles, I see that there are difficulties, there are challenges, there are problems, because universal or UDL acknowledges that multiple opportunities for representation and for engagement makes for a better learning experience. But in terms of representation, modalities are limited. I'm a science librarian, and my colleague is an OER librarian. So we are pretty much generalists in our own discipline. But in terms of OER, she's worked a lot with, at City Tech, computer science and engineering faculty. And I've worked with computer science faculty on my campus. And just anecdotally, we've learned that some faculty will have classes in programming or in other kinds of advanced concepts that have to use paper and pencil because they want to make sure that the class is level set. So they're saying, if you have your own laptop, you want to use that, sure, but they're designing their class so that students can learn theory of the concepts on paper and pencil because they want to make sure it's fair for everyone. So they can't say, all right, pull out your MacBook and let's go. You can't do that if you know that you're not providing that. And so that kind of representation, those different modalities aren't really available. We know a lecture style class isn't going to work for everyone. If a faculty member is standing in front of the room and saying, all right, let's go and learn some R, and then they lecture at you for an hour, type everything out perfectly, and then you walk out and you're like, okay, that seems easy. Go home and you do it, it's hard. That's really discouraging. That's happened to me before in a class. And then action and expression. So in the classroom setting, students aren't really getting that opportunity to act, to express. And if they're not interacting in the moment, if they're not getting feedback in the moment, they go home, they try something, it doesn't work. They don't have someone to talk to troubleshoot. They don't really have that opportunity to say, hey, I need some help, I need advice on what I did wrong, what's wrong with the syntax here. They don't really even know how to interpret errors. And as we've seen here from the last presentation, AI can actually help with some of those things. You can actually throw things into different AI and understand what your errors mean. So that's great. That's one application that students can use, but across the board, that is an issue in terms of just how they're learning the materials. And then engagement. So UDL encourages teachers, professors to look for different ways of motivating students to engage with the work. But if they're not having that opportunity in the classroom, if they're hitting barrier after barrier and getting frustrated, then they will be less engaged with the material and they will be more likely to just leave that field. And within our study, we did see that the motivations that students have for choosing their major does have to do with just the facility of it, their interest in it, their future prospects. And there's a significant difference in the motivation of computer science majors compared to non-computer science majors, looking at just forward prospects. So the prospect of job opportunities or a higher pay upon graduating. That's what's motivating them. It's not necessarily always just interest in the material. And they are having challenges. About 80% of our respondents said that they had challenges in their coursework, and in 90% of the cases, it was because the material was challenging. It was difficult to understand. And if they're not really having an opportunity to get feedback on it, to get help with it, to practice it, and practice it, and practice it, then that challenge isn't really going to be getting results. So really, it's laying out a lot of the barriers and the challenges right now. So before we move, I do want to kind of move into other positive things. So looking at ways that you have sort of either seen these challenges or overcome these challenges. But before that, do you have any questions for me?
So I was really intrigued by your finding about the labs, because I know that labs have kind of been hotly debated in some circles. There's also, especially for libraries, talk about more lending of laptops and things like that. Did your data indicate a preference for students? Because since they prefer to be working at home, maybe the laptop might be good, but the laptop is generally, for the value that the college puts out, gonna be less than the desktop they can get to put in the lab.
Thank you, very true. So there wasn't necessarily anything, I don't think any of our questions looked at that specifically. So I can't say that there was or there wasn't a preference. At my campus at least, I know that laptop loads typically happen for 3 days. And we've extended it to 7 days because fewer students are requesting laptops at this point. But that just knowledge that you can only borrow a laptop for a couple of days is, you know, one of the barriers. And then another is that students just don't know that those kinds of things exist. Many students reported not knowing that laptop learning was an option. Think about 5% of students who were seniors didn't know that there were computer labs on their campuses. Yes, exactly. And that's all very startling. And so, you know, understanding that there is the problem of just having the equipment, having it be up to date, having it be actually, like, some of our laptops are on their way out. They're not booting up properly. And so, you know, we all know that there are a lot of constraints when it comes to just having the equipment that we need and having the resources that we need. But I think also just students not realizing the resources that are available of the ones that we have is also a challenge that we have to address.
I have a related question as to whether classes that were held in labs, if there are questions to the students about, they find it useful, you have a challenge in keeping them maintained properly, like bring in your own laptop and put it next to the computer lab's computer.
Yeah, we didn't ask that either, but at least for my own knowledge, in the library, in my library, I'm at the reference desk a couple hours a week, and our reference desk faces a computer lab with about 150 computers. We have computer labs on 3 different floors of the library, and we're all essentially lab managers. So we do get a lot of, like, can you help us with a printing question? But we have computers on in like study carrel style settings, and students will have a computer, they're all Windows computers, and they'll have something like a Mac next to it, and they'll use both of them simultaneously because they'll have different needs in that moment, or they'll have a paper that they're writing, and they'll just scooch over the keyboard and just use their own laptop because they're using it just for the setting. But for different classes, for computer science classes and other classes, they did have different needs. So that was indicated in the results. It's just that the way that they work in those different disciplines will vary. Because something like an English class, you can use Google Docs for your entire career and you're totally fine. You don't have to worry about it. But if you're taking a class that doesn't have its own specialty software and a software that's fully compatible with the Windows computer, fully compatible with Mac, you're gonna have that challenge in that kind of stuff.
That's interesting. I mean, you actually leverage it, but you've gotten that because like, are we maybe making decisions about technology that are gatekeepers?
Possible, yeah. I think that it's hard to catch every situation. And so, you know, we're gonna try and make the decision that will benefit the most students. And in the case that most students are not computer science students or not tech students, then a lot of the decisions we're making are great for the majority, but for this particular population, then they might not be the best. And so we might have to think about how to best accommodate different disciplines. On our campus, we have one particular building that is where the majority of the computer science classes are held, and so they have labs for Java, for example, and they like there'll be different labs for different programming types, for different kinds of concepts. So something like AI will have its own lab, and there'll be computers that are $10,000, and then other rooms will have $2,000 computers because you need different power for those things.
Those are the cool labs.
Those are,
Yeah.
yes.
Is there any discussion about, cloud? Because, for example, if there's a central location that has computers that are up to spec to do, advanced tasks, but somebody can access it from their phone or from a Chromebook as part of the service of the school, that kind of expands the reach of, the computer resource.
I'm positive there are discussions, I'm not part of them, but we do have it used to be called the virtual desktop, I forget what it's called now, but CUNY does provide that kind of service for certain programs. So something like, RStudio and ArcGIS and, the SPSS, those programs, which have very high costs and are, subscription based, are on a cloud server, and students are able to just log into them and use them. But it might then be a question of just the people who maintain that better understanding other kinds of programs that need to be on those computers. Because I don't think students are able to download programs or install programs if they are using one of the cloud computers. But it exists, the structure for that exists, the resources for that exist. But a lot of the programs that the students are using for their classes in like very niche and nuanced ways aren't on there. Like I think MATLAB is on there, but that's pretty much the most of it. There is a list of the programs that are on that site, but you know, what CUNY Central is organizing and managing what we're doing can vary a bit, or like what we're able to do. And so that I think is just one of those limitations and understanding what's possible and then what is being done. You're welcome. All right, so I did have some discussion questions, but I think this was great. How am I doing on time?
I think you've got at least 10 minutes.
I think 10 minutes, the next person starts, so 5 minutes.
Oh, yeah, that's fine. So I guess in your own experiences, in your classes, do you find that there are like constraints that you have? This one might be a little bit more wordy than we need to be, but do you find that the lack of technology in your own classes has been a barrier to what you can do with your students? And can you tell us a little bit about like how or why you think that is maybe changing your pedagogy or changing the approaches that you can take here?
There is no actual plan for renewal of resources. And it has to be, every 5 years, new computers need to be replaced, right? So,
In my grad program, I noticed that a majority of the tools that we used were web-based. So it kind of cut the expense for like software or like having to pay for those things out of pocket. And I guess it's like a little contrarian, but like one of the things I appreciated is the fact that most of these web-based technologies were available at like no additional cost as a matter of CUNY. So I found that my instructors like try to kind of follow the model of like open educational resources and like making sure that students just, number one, have access or can like use these applications by virtue of their, membership as a student. So I've had like more of a positive experience with it. And also like using Python and like language processing in the libraries and so forth. So it's like expensive and not necessarily applied depending on what you're doing. But it might.
Great, I'm always happy to hear a good story. And I was also a CUNY graduate, I did a lot of like tech work, and it was really during the pandemic that shift, like I really was aware of how badly it could go. And I did it in grad school, and so everything was very much dedicated to making sure we were taking classes in computer labs, and that was really helpful. But I had a semester where I started learning R in a lab. Every single student had a computer, and then halfway through, we all went remote, and it was terrible. It was a really challenging experience, and I will never like R for that reason. Like, it's great, it's fine, Python forever, okay, Python until I die, because of how that experience like really impacted the way I learned the material, and the way that I could practice it. Watching someone else write code beautifully and then having to figure out, you know, the logic of how they got to that point. While they were explaining it, everything seemed to make sense. And then as soon as we ended that call and I had to do it myself, even 5 minutes after, it's just like, what? Why parentheses? And so you know, that's one of those things that can definitely happen and just impact the way that engagement and understanding happens. So I'll wait for you.
If we have time for another question, the question of, looking at the resources available to students on campus and off. This sounds great, that he looks at so many things here, and I'd like to see your paper afterward. I'm looking at the last sentence or the last phrase in your question, and I don't teach our programming courses, even if I'm a chair of math and computer science. But having appropriate resources on campus, so useful for skill testing. But this is just a bit of a can of I think we have to see what our expectations are going to be as students going forward and starting their careers with AI being able to do much of the lower level programming that we're teaching our students to do. And this is not unique to computer science courses. But as you mentioned at the start, we are pumping students out at a huge rate, which is wonderful if they can start at a position where there are jobs available. So wondering here or afterwards, people are looking at using AI to do some of the lower level programming tasks with students in their classes.
I think that might be a discussion for, but I did want to share this one last thing. But I didn't want to just bring up problems and then not really have an opportunity for solution. So we mentioned in our abstract of the EducateAI initiative, and so this is an NSF initiative that is looking at skill training and access and just resources. And so this is actually a series of 7 or 5 NSF grants and then 2 public or private organizations that provide grant funding for infrastructure building. And so we wanted to make sure that there was an opportunity to just find new funds. You know, the mayor's office may be one avenue, but it might not. You know, we everything's up in the air at this point until we actually see a final contract. Everything's up in the air. And so just other avenues, we wanted to be able to present and just give you opportunities. So the EducateAI initiative was opened up in January of 2023, and it's sort of like a notice of special interest kind of thing. And so that very first grant is specific for, rather this one, is specifically funded for directed or tied to it, but all the others are for infrastructure building, providing new technology and equipment. So yeah, there's a QR code, you can find the slide right there.
Thank you very much.